Good morning and good afternoon, everyone. We're going to go ahead and get started with today's Wednesday webinar. So today we're going to take a look at SolidWorks PCB powered by Altium. This is a brand new product for SolidWorks. It's been available for about a year. My name is Scott Davis. I'm the product manager here at Hawk Ridge Systems for the SolidWorks PCB products. SolidWorks PCB was an addition to the current SolidWorks portfolio, which now allows for full, complete electronic design and integrate into the SolidWorks portfolio. We're going to focus on the electronic design applications today, where we'll be designing a simple circuit for schematic capture, circuit board layout, and we'll be doing all of the outputs. So as you know, today's products are all highly integrated with electronics, mechanical parts, and provide customers with the demanding technology that we see in today's markets moving forward. SolidWorks PCB powered by Altium is a full schematic capture tool. It's traditional two-dimensional PC board layout tool as well, integrated. Contains a 3D visualization module, which allows you to look at your 3D models, place components in a 3D mode, and view the assembly from a 3D perspective. Included in the high value proposition we have with SolidWorks PCB is the mechanical collaboration with SolidWorks. We've demonstrated this on previous webinars, and it is included in the product. Today's webinar, we're going to focus more on circuit design, circuit layout, but certainly the mechanical collaboration is the technology differentiator in today's ECAD industry. Also allowing SolidWorks electrical integration with your circuit boards. So using SolidWorks Electrical, you can design cable harnesses with connectors, attach these connectors to the PCBs, and see the entire assembly in SolidWorks 3D CAD. Incorporating the entire ecosystem. So this product really rounds out one of the missing pieces that SolidWorks previously had, and that's the ability to design electronics. Today's roadmap looks like schematic design, simple circuit, PCB design, a simple two-layer board layout, demonstrating to you how we have all the incorporated outputs available, and complete the project. So let's get started with the simple circuit for schematic design. Turning to SolidWorks PCB, I do have a project started, my Hawk project, which contains a blank schematic, contains a blank PCB, which we will use to design our layout, and we'll use the schematic to add the parts and do the wiring. So from the library panel, we activate our available libraries. I'm going to demonstrate a couple of different ways to add components to this schematic. The first one being just a simple drag and drop from the pane onto the work surface. So we're going to add a couple of transistors here, get those onto the work surface. Then we'll move to our battery, which will power our circuit. Now we'll get a couple of capacitors. Add those onto our circuit. That's the wrong capacitor. I prefer this one. We do have polarized capacitors, so we want to get those positioned correctly onto our circuit. Okay. So another way we can add components to this circuit is by a simple right-click, place, part. You can see most of the commonly used commands are available from a right-click on the work surface, making high productivity, high efficient circuit design. The tool is tab-driven, ribbon-driven, easy to see icons and easy to understand commands, which is inspired by SolidWorks user interface, keeping the tools and the applications in that common feel for users of SolidWorks products. So by placing a part here, I can search my library and grab my resistor. And the first one pops onto the cursor. The nice feature about this is that by just adding another click, the next resistor pops right onto the cursor. So if I'm placing multiple components, it becomes much faster and easier just by clicking through, as many of these components as I need for my circuit. The last item we're going to grab is an LED, and we'll get our red LED. Place 2 of those. Now we have all of our components for our simple circuit positioned onto the workspace. And now we can simply just wire this thing up for the connectivity, which is going to create the nets. And then we'll move forward with setting our reference designators, compiling our schematic, associating it to the layout, place and route the entire design. Okay. So we're finished with the library panel. We'll close that. I mentioned again, all tab-driven, icons are very simplistic, easy to understand. And we're just going to go up here and select our wire function and begin to wire our schematic. You'll notice that when I click on to an active pin, I get the red indicator, meaning that is a connection point. And I can do that throughout my design. All right, so I'm going to go ahead and wire this up real quick and show you how quickly and easily it is for SolidWorks PCB schematic to connect all of my active pins. Okay. Very simply, quickly, easy to connect my entire circuit and form the completed electronic circuit. Clicking through here, I'm going to get all of my power pins for my resistors connected, and then finish up my cross connection to my transistors. Okay, my final connection, I can change the wire mode to an angular type approach, giving me my cross connection to transistors. Now I have completely connected my circuit. I'm ready to move forward with assigning my reference designators, doing the compile, which will collaborate the footprints, wire the connections, and associate to the circuit board. So from the Tools menu, my Annotation button is available here. So I annotate this schematic, which clearly you see that all of my reference designators have question marks, which is typically common when you design a circuit. You may be doing multiple pages. You may choose to set your reference designators manually, or certainly you can allow the tool to do that, which that's what we're going to do in this case. So we're going to update these changes, and we have 11 components that need to be assigned, and it's already assigned all 11. We accept those changes. We get the list of the changes. We execute the change order, ECO if you will. And now we have reference designators assigned to our schematic, which in turn would be reflected on any bill of materials, net list pin configurations, items like that. Okay. So the next step would be to compile this schematic. You can set electrical error reporting for power pins, open nets, nets with the wrong inputs, the wrong outputs connected. This is extremely simple circuit on purpose, mainly due to, we keep these to an hour. We have a lot to show you, so I want to try to make this easy and simple and give you the overall view of the ease of use of the tool and the flexibility and the ability to pretty much design any type of technology circuit board that the industry needs today. So we go back to the Home tab, and under our project icon, we have compile the schematic. Okay, now we've compiled the schematic. Okay, so we're ready to move forward into the circuit board layout. Okay. So with that circuit board design ready to go now, we've completed the schematic design. I showed you how to pull components from the library in 2 different fashions. I showed you quickly and easily how to wire a schematic. We completed the annotation, assigning the reference designators, compiled, and now we'll move to associate the PCB design data. So in the PCB design portion, we're going to move to the circuit board layout. Returning to SolidWorks PCB, and we'll open up our blank board. And again, from the project icon, I can simply just import the changes from the schematic. So in that fashion, that application, it has pulled in the associated footprints. It has made the proper connections to the pins. And now I'm going to place and route this simple circuit. Drop these components down here a little bit for ease of placement. 2, 3, 4. All right. So let's get started with our component placement. I have the grid set to 25. That's pretty common for circuit design. You certainly have the flexibility to change the grid, change the trace width. Everything's extremely flexible and very easy to activate in this tool. You can see also that the PCB portion is also completely tab-driven, ribbon-driven, simple icons, easy to find the activity that you need to do. Similar to the schematic, most everything is found on the Home tab, the most commonly used commands. Not everything, but the most commonly used commands for sure. Get our capacitors in place here. And then I'll move to pulling in all of my resistors. So that I can see by the guide wires, the location that I need the pins to be and follow my circuit wiring diagram. I can also cross probe from the schematic if necessary. If I wanted to locate a particular component first, before I place it on the schematic, or place it on the PCB, I can certainly do that as well. Okay, now we have rough proximity placement for the schematic. Board size adjustment, completely up to the user. I pre-adjusted the board just to save a little bit of time and give my working space a good graphical representation of the components. Okay, this is a 2-layer board. Most of the routing we're going to go ahead and put on the back. We will have one trace on the top where we have the crossover. So with that, I'm going to go ahead and get started with the wiring. So again, from the Home tab, simple route. Okay, I'm an active cursor. I move on to the pin. I get my circular representation that I'm on an active connection, and I can select that pin. I switch to the bottom, which is the yellow color, and now I'm just quickly going to connect up this circuit and show you the completed layout. Back that up a bit here. Let's go to by Backspace. I can back up to the proper connection, that guy, and then we'll grab the other power pin of the diode, grab the resistors, get those put in place, and finish up the remaining connections. Again, this is a fairly simplistic circuit on purpose. I have done multiple designs with the tool, some very complex, some extremely simple. The tool supports all of the technologies that you would need to design for today's products. Okay, we're going to finish up here with our cross and move into configuring our outputs. Okay, here I don't want any vias, so I can just switch layers, and now I'm on the top of the board, and in just a matter of minutes I have a complete 2-layer layout matching my schematic, and can now create all of my outputs and do all of my documentation. Okay. So during the circuit board design piece, we saw demonstrated easy component placement as the compilation of the schematic automatically pulls those footprints from the library, placing them on the work surface, automatically doing the electronic connections driven by our schematic. We completed the trace routing, and I'm going to add that drill table, which represents the holes, the quantities, the graphical representations for the drawing. And then we'll move to the outputs. I will show you the ease of configuration for all manufacturing outputs for the bare PCB, schematic bill of materials, assembly files, drill files, everything necessary to create the assembled PCB and PCBA. So back onto our circuit board design, 2-layer board. Typically, as you know, we would have extreme amount of documentation describing our board material, our silkscreen colors, solder mask colors, IPC specification for manufacturing. That's a lot of detail. I could certainly create that into a template and pull that into this design. I do want to add the drill table, again, so you can see the ease and the accuracy of this information coming into the design. From the Home tab, I have a simple drill table icon, By clicking that, it creates the drill table with the accurate number of quantities and graphical representation of my hole sizes. So these are all plated through holes, PTH, and the hole drills are round. And we've got 3 different symbols showing the 3 different sizes of holes that we have in our design. The remaining outputs are very easy to configure and easy to execute. So on my Outputs tab, I have all of the individual outputs available if I choose to configure them and run them independently. Okay. I can also, from the Home tab, I can go to the project icon and I can pull up the Generate Outputs dialog. Now with this dialog, I've already pre-configured all of the items that I want to output. So I've configured a bill of materials, my schematic prints, my PCB prints, my NC drill files, my ODB++ files. I prefer ODB++ versus Gerber. The new format being widely adopted is the IPC 2581. ODB and IPC 2581 are much more intelligent than Gerber. When you load this into PCB manufacturing engineering software, the intelligence will be included. Component information, net information, via information. So I prefer to use this. It's one single type of a file and very easy for all manufacturers to utilize this type of an output, whether it be a North American PCB manufacturer or a manufacturer overseas. This is a worldwide standard used by all circuit board manufacturers and used by most assembly vendors as well. It does contain component information. I'm going to go ahead and generate a pick and place file for this board. Even though it's through hole, we all know that there are automated machinery for assembling through hole boards. So I have these items checked and I can generate all my outputs with one click. There, I've generated all of my outputs and is placed the outputs in the project panel. Okay, so by opening each of these items, I can see there are all of my ODB folder information. That would be zipped up and sent to the vendor. The BOM creates an Excel spreadsheet in the format that I choose. So I could add additional items from my parameters on my components that may be important to your company. One being, obviously, your company's part numbers. These are all generic miscellaneous parts, so I've used just the generic information. You can add manufacturer's part number, manufacturer, component part number, and any other additional parameters that you may need. The NC drill file is going to be just the XY position file and the tool number. This is a standard format again in the industry. Again, simply and easily created with a touch of a button. And I have also created our pick and place file. So here we have a representation of the individual components, the type of footprint, and the exact XY location of the library origin, and the rotation, which again is very important when you're doing assembly for polarized components and components with specific pin 1 indicators. So that is all contained now in my project. So when I save this project, save all, I can get everything saved for the project. So just go to project, save all. There, everything's now been saved, and I can go back and look at my documentation. So PDFs are created in the configuration that I selected. This is our top layer where we just had the single trace. We have the bottom layer with those traces. We have our silkscreen overlay layer. This is going to be printed onto the board, typically using white epoxy ink. Our drill table and our schematic. Also, everything contained in one PDF. This is a smart PDF. Can be utilized for cross-probing, assembly instructions, various other activities. Okay, so that was our outputs portion, where we looked at bill of materials, manufacturing files for circuit board PCB, circuit board assembly, PCBA, and all of our documentation associated with our design. So with that concludes really the design of the project using SolidWorks PCB. Like I mentioned, we do have our SolidWorks Integration, where we can simply pull and push boards from our database and load them into SolidWorks.